The students then log on to the school's VLE to search for information that will help reinforce and explain what they found out from their practical investigation.
Well, in the shared network that we can all get to, Mr Mason's got a folder just for Year 11s. And then there's usually like internet links and stuff on that help us with answering the questions and stuff.
We've got like worksheets that we can work through, and then on some of the worksheets we've got like links to PowerPoints just to help us and like help understand the work that we've been set.
They're just like all different worksheets like to help you, and like what we do in lessons, and just like put on there and then Sir does them on the board and just explain more.
What we decided to do as a staff team was use 21st Century Science, which is the Year 10 and Year 11 GCSEs, and for staff and for students we decided to break down each of the topics into smart notebooks, and what we've done is basically broken down the lessons and included all the resources that you would need to successfully teach these lessons in the attachments on the side. We've also included the GCSE mark scheme for additional science, the hope being that they'll be able to self-assess where they are on the mark scheme and also find what they need to do in order to get to the higher levels. We also have got some live links to the Alchemy website by the RSC, and on the simulations page, which a lot of the students are using today, we'll link to external simulations.
There's just a page on here which is a link to this website, and it just like shows you like if the temperature's cooler, the reaction's slower, and if like you make the temperature higher, the reactions gets faster and it turn green when they've collided together.
We found that using textbooks in lessons and allowing students to take textbooks home resulted in a high cost basically, but they've always got something which they can pin their understanding around. There is a very clear lesson framework. Yeah, we found the software useful because, as you can see, we can vary the concentration of the particles quite easily. We can change the temperature, giving the particles more or less kinetic energy. This goes a little bit deeper into particle theory and hopefully helps the students understand the difference between an ineffective and an effective collision.
You can like change like things like the temperature and different variables like the concentration, and then see how many like collisions and reactions occur. This is the reaction time, and in 12 seconds there's been 26 collisions but only 11 reactions. If you put the temperature all the way to 10 and do the same amount of time, there's much more reactions, so it makes more effective collisions.
We find it's incredibly powerful in helping students to visualise the mechanics of the reactions, which then feeds back into their coursework and hopefully will help them succeed and get the highest possible levels.
Increased temperature, the reactions will happen faster because the particles get more kinetic energy from the heat, and when they collide, a reaction will occur.
And the work they're doing today and in previous lessons has been choosing one of these particular techniques upon which they're going to base their coursework. So we're doing preliminary work at the moment, so we're really giving them a sound grounding of the choices to make about variables, about ranges, about equipment, and then the interpretation of their preliminary experiments, so that when they go on and actually do their final investigation, they have a much higher chance of being successful and getting the marks of which they're capable.
I think it's better, it's easier this way than a teacher telling you, because you can relate to it more. It's a bit easier. Yeah, because you can actually see it and you can look back at it. Exactly.
Visualise it as well, rather than just words. You can see what's going on.
Yeah, it's and because you can look back at it whenever you want, and you can access it from any computer in school. You can go into any computer room or a computer that's in a room, and you can get it from anybody's desktop.
We had our first year group go through with the additional science investigation, and we were really pleased with a 94.5% A to C for those students. Even more pleasing was the levels of their coursework, which for many students exceeded what their potential attainment would have been for their examinations. So we did hopefully find that by providing high quality digital images, digital software, that we're able to help students really improve their overall GCSEs.
I think it's like better because you can like watch it and understand like the science behind the experiment that you don't get to see occur when you do the experiment, and it just kind of explains it a bit more.
All the information's there really for you, and sometimes it's easier if the teacher's behind you to explain what's going on, but if we've done it like we have done today, where you see the reaction and then you see the actual reaction occurring on the computer, it's a lot easier than just seeing what actually happens.
And what were we measuring?
Pete Hoskins at Westborough High School in West Yorkshire is working with his Year 7s to create visual comic strip presentations that describe the experiments they've done.
It's part of a series of lessons that they've done on particles, and within that we've been looking particularly at modelling and trying to get across the idea that particles behave differently in solids, liquids and gases.
Can you make sure, please, that you've got your goggles on?
Their practical investigation into the particle model involves looking at the viscosity of oil.
So the pupils simply had 2 temperatures of oil and then had to pour that through a funnel and then time how quickly each oil came through the funnel to actually see if the temperature affected the time.
So was it 4.90?
Yeah, Miss 4.90.
You need to write that one.
We can talk about a whole range of things, such as which variables we're changing, what are we measuring, what do we need to actually keep the same in terms of control variables. We can start to look at the quality of the data they collect and how they might interpret it.
So we've took one, so shall we not take another one?
How many did I say you need?
5.
Okay, including one of that. So if you've got one, how many more have you got to do? At least another
3.
3. Which of the 2 oils comes through the fastest? Hot or cold?
Hot.
Hot. So if that's the case, if you were to describe the oil as runny or less runny, which one would be the runniest?
Hot one.
The hot. What does that tell us? The class itself is our lower set class, and you've got pupils in there who would be level 2, level 3 in terms of national curriculum, and reading ages which might be anything from 7 years old.
Remember, you've got to take your photographs.
And then, of course, we asked them to take a number of pictures. The focus of that, what we wanted was for them to familiarise themselves with the apparatus first and foremost, to then start thinking about what it was they were changing and what they were measuring, start thinking about the actual procedure itself.
The laptops are then set up so the class can start using the comic strip software.
Now that should recognise it now, that's fine. The comic strip programme, it's really just a tool to produce comic strips, and as such, it's just a series of templates that you can actually use. As long as you've got some digital photographs there, you can drag them into the template and then add a whole range of speech bubbles and various effects as well. So, which of your pictures comes first?
This one.
Can you click and drag? Okay. And can you explain what you were doing there?
The cold oil.
Did you do the cold oil first? So get a speech bubble, put it in, drag it up. Okay. If you want to make the bubble bigger, then you can double click on the bubble and then just make it bigger. But try and just explain now what you were doing. So what did you say you were doing?
We were putting the cold oil into the filter.
So you would put the cold oil in. What were you measuring?
How fast
Okay, so write that in, okay?
we wrote our seconds, how much second did it, like the hot or cold, how long did it take to go down, and I'm writing it, this is the hot and that's the cold water, and which one went faster and stuff.
I need to do another picture of me. Because that's a picture of me, but it's upside down.
Right, you can put it in here and you can spin it round. Put it in that one. We sat down and we thought about how we can actually go about trying to produce, in particular, assessments which would allow the pupils to put forward their understanding and to express their understanding other than something that was obviously just going to be paper-based because of the literacy levels. And they really enjoyed actually putting those strips together and actually looking at their own photographs. But it was the discussions, I think, that took place around that production of the comic strip which was particularly strong.
We're changing the...
You had two different types of oil, didn't you? What was the difference?
Hot and cold.
Right, hot and cold.
Hot.
And what were you then measuring?
The... jug? No, I think.
What
the
piece
oil?
of equipment were you measuring? What piece of equipment were you using to measure? As you poured the oil through, what do you start and stop?
Stopwatch.
Okay, so you're measuring what?
The stopwatch.
Oh, a stopwatch helps us to measure what?
The time that the oil dripped down.
Great, the time. So, what do you find out from your experiment? Which of the two, the hot or the cold, seem to go through the quickest?
The hot.
The hot?
By 3 point something seconds.
I think that the majority of them did get it. I mean, they still need a little bit of coaxing. There are one or two pupils who I can see their understanding is still, not assured. There's still doubt in their mind. And so as a classroom teacher now, I can see who in the class actually has got a strong knowledge of particles and who is still unsure about it. So obviously that can now be addressed in future lessons.
The pupils go on to use some simple animation software that the teacher had set up to model the movement of particles in solids, liquids and gases.
The scratch animations were just an extension of some work that they've done on modelling already. And again, it was really done as an opportunity to assess their understanding of their previous lessons. And the visual nature of it, and also in terms of the audio and putting in the sound files, it really does show whether those pupils themselves really understand whether or not a particle in a solid might be vibrating or what it would actually look like. What did you say to me before, though? We said it was what?
Like a smoke, but it's kind of like steam, a cloud.
Was it a gas? Is it going really, really fast?
No, so it's going slow. It's liquid.
So it's a liquid, so we need to change what to it?
The cloud bit.
And change it to what? A picture of?
A picture of what? That one.
Of water, good. We made a conscious decision not to have a process where they would have to write a lot, because we just understood from the start that wouldn't allow them to express their understanding. I think that the strength of it is not so much in the comic life strips and the experiment at the start, or indeed the scratch animations at the end. It's the two things together. And I think at the end of the process, when you sit down and they can actually see those animations on the Scratch program, and they can actually make those choices and decisions that they've actually got to make. That's when you really see if they understand how these particles are actually behaving.
So in the hot, the particles spread out, and in the cold, the particles be together.
Okay, so they're closer together, yeah? So in the hot, are they moving slowly or quickly or what?
They're moving quickly.
Okay, excellent. So we started to look at their ability to explain models of particles. They were coming out at level 4, whereas on a written test, the same pupils were level 3. So it was very powerful to us and a great indicator of where we want to go for the future.